Lecture 15, the covariant form of the Killing equation. From the previous lecture, 14b, you see, the Killing equation are, you see, I just copy from the previous lecture this equation 4. Now, we will transform this equation using covariant form. See? So, apply the Leibniz rule. This is the product rule. You see, you just expand this product here and two terms, okay? Just apply the product rule. Likewise, this case, similarly, expand this, okay? It's quite easy, okay? That's the product rule, okay? This is similarly to this one. And you note that I can isolate, okay, this term over here, which is there, which, look at here, look. This is a partial xi, gmj xm, minus xm, partial gmj xi. Likewise, similarly, you can write gim, okay? That's this is a derivative of the product minus this relation. See, this is from calculus, okay? Now, we can substitute, okay, on this equation over here. So, this leads, okay, to minus sign over here. And this I can write, okay? I just substitute. It's quite easy. Again, take a piece of paper and write down. You see clearly what I'm doing. So, this over here, attention now, you see k here and k here. I can substitute this dummy by n, you see, no problem. So, I can combine this term, this is minus here, xm, you see, you just look at here and look at there. You say it's simple, quite simple. So you just copy from here to here. So this, as we derived in previous lectures, okay, this is exactly 2. This is a Christoffel symbols of first kind. You see, you just impose the covariance of the tensor G is equal to 0. This will lead to the Christoffel symbols of the first kind. This is 2 times. Then, from here, I can combine this term here with one of these. This is 2, okay? 2 times this. So this one comes here and the other one comes there. It's quite easy. And also, you apply the property gmg xm is xj. gmj xm is xj. Likewise, gim xm is xi. You see, I just substitute, and this I combine. One term with a negative sign, you see, one term with a negative sign, and another term with a negative sign. This is twice. Now, you see, this over here is the covariant derivative, okay, of xj, you see, here. Now, this one is the covariant derivative with respect to xj. This xi and xj, you see, covariant derivative with respect to xi of the tangent vector xj. This derivative with respect to xj of the tangent vector xi. So, xi is the Killing vector, okay? If this equation, you obeyed this equation, the x, capital X, is the Killing vector. You see, you have a curve in which you have this behavior, so the tangent vector to that curve okay? This called Killing vector. See, there's a Killing equation. I will give a next lecture one example, say, just to apply this Killing vector, Killing equations, okay? Written in terms of the covariant derivative. It's the same, you see? It's the same equation, okay? So this is represented by the covariant form of this Killing equation over here. You see, that's it.